terminology. Take a look at the top there, a to the exponent n. So this whole thing together is called a power. The base is the big number, the bottom at the base, and the little number is the exponent. Sometimes we get a bit lazy and we say, oh, we're just multiplying exponents or dividing exponents. Really, you're multiplying powers. Okay, that's the whole thing here. We might then, based on the operation that we're using, multiply or add or subtract the exponents, but really we're doing operations with the whole power. Okay, sometimes we also say, for example, the first one, you'll hear people say 3 to the exponent 6. That's the full-on proper way. 3 to the power 6, we might use as well. We understand it means the same thing, but technically it should be 3 to the exponent 6. We just kind of interchange them a little bit. So here, the whole power is 3 to the 6. We just copy that out. The base is 3. The exponent is 6. The coefficient is any number that's in front of the 3. Well, there isn't anything there. Or maybe I shouldn't put an x. You might think it's a variable. So I'll put none. Okay. Now the next one is a variable expression. Okay. It does have a coefficient in this one. So it's 5 times a power. So here the power is x cubed, not 5. The base of that is x. The exponent is the 3, and the coefficient is the 5. Okay. So if there's nothing shown in between 5 and a variable, it means multiplied. We call it a coefficient. So here are those rules that we expect you to know from Math 9. Remember, from Math 9. So when you're multiplying powers with the same base, that's the key. They have to be the same base. Then you add the exponents. When you divide powers with the same base, you subtract the exponents, either using that old school division symbol or a fraction symbol. Power of a power, we multiply the exponents together. Then remember that anything raised to an exponent 0 has a value of 1. You can just, it's almost the easiest thing ever. Anything to the exponent 0, you just give it a value of 1. Power of a product, take a look. So we have to take each factor and raise it to the exponent m. So these are equivalent. We might go one way, we might go the other way. Depends on the question. And same with the quotient. If there's brackets around the whole thing, we have to apply the exponent to both the numerator and denominator. If there's no brackets, then you have to look closely. Where is that exponent? Okay, so what should you think of when evaluating 6 squared? So evaluating means find the value. So what is a power, the short form of? What operation is the short form of? Multiplication. Yes, so 6 squared means 6 times 6. So what should you think of? Multiplication. Repeated multiplication, basically, because you're using the same base. Now, sometimes we will have negatives. We've got to be careful with it. So without your calculator, and then you can check with a calculator. So negative 3 in brackets squared. Hands up if you think it is negative 6. Positive 6. Think again. Negative 9, hands up. Positive 9. Okay. Yeah, so remember, it's repeated multiplication. So negative 3 times negative 3 is positive 9. Anytime you square a negative in the brackets, it's positive. Take a look at the next one. Where are the brackets? They're just around 3. So that means negative 3 times 3, which is negative 9. So looking at the placement of the negative is really, really important. Same with the next one. That 2 only applies to the 3. So this is negative 3 times 3, which is negative 9. So if you're lazy in your calculator, when you put in, for the first one, the bracket, you can get out your calculator if you want. If you don't put in the bracket and you just go negative 3 squared, you get negative 9. You have to put exactly what it says there. You're going to use your calculator. It's even easier to use your brain, right? So negative 3 in the brackets is positive 9. So is the placement of brackets? Yes, it's important. Okay, now we're using the rules. Some have variables, some have numbers. Okay, powers with the same base is the most important thing to look at. Okay, and the base remains the same. Okay, so is that correct? No, what's wrong? What did I do wrong? Right. I multiplied the 5s, and that's incorrect. Okay, so it was my exponent correct? Yep, it was. So when you're multiplying powers with the same base, you add the exponents, right? 5 cubed, I visualize it in my head as 3 5s multiplied together, multiplied by another 6 5s. So in total, I have 9 of them. Okay. Next one, they're all variables. Are they the same? Yep. It's almost easier with variables because there's no, oh, I'm not going to make that like 2w or w squared or whatever. It's just going to be w to the 6. Multiplying powers with the same base. Please try your best at your writing. That is very difficult for me to really think that it's a power. Okay? Looks like W6. It looks like W times 6. Okay, so please try to make it different sizes for the exponent. Okay, dividing with the same base. Sometimes I'll get students tell me this. Is that right? No. So what's an error that was made on that one? Hands up. Yep. I divided by the 5s, right. Was my exponent correct? No, why? You have to subtract 26. Right, and I divided, right? Yeah. Right. So I divided the bases and I divided the exponents which made it a double error. Okay, so this should be 5 to the exponent 4. And again, how I visualize it, I've got 6 5s in the numerator, 2 5s in the denominator. So I divide out the 2 5s, I've got 4 left in the numerator. That's back to Math 9 stuff, so hopefully you remember that. Take a look here. The bases have to be exactly the same, and they are. They've got brackets, but they're exactly the same. So I keep them. Don't just get rid of the brackets. Keep the same, and then I'm subtracting, so the exponent is 6. Okay? Yes, my final answer, if I were to evaluate, would be positive, because it's an even exponent, but we weren't asked to. It says simplify and leave in exponential form. Okay, next one. Is that correct? No. Okay, hands up for someone else to tell me what I did wrong. Okay, Matei.
You did 2 plus 3.
Yep.
You're not supposed to do. It's supposed to be 2 times.
Right, power of a power. So I got the base right, but I need to multiply those exponents together. Okay. And so the next one, base is easy to stay the same. 5 times 3 is 15. Oops, sorry. Okay. Then it says express as a product or quotient of powers. So I'm going to use those laws that were at the bottom row of that chart. Okay, these ones here. So it's given in this form, I have to show it as a product of powers. Given as a fraction, show it as a quotient. So this means I'm going to show this as 3 to the 4th, 4, times 5 to the 4. Now, you might want to use just a dot to represent multiplication, just in case your multiplication looks like a variable x. And then it doesn't say to evaluate, it just says express as a product or quotient. So here, this one, be careful because that -4 was in the brackets, so I've got to keep the -4 in brackets. And then I'm going to use a dot this time. And then I don't need brackets on the 2 because it's a positive. Okay, so you can put brackets, totally fine. But that's what it's going to be. Okay, you guys doing these? Done them? Okay, variables, same thing. W to the 8, Z to the 8. I put a little line through it. If it's variables, you don't need a multiplication symbol. It's understood to be multiplying. Okay. Now some fractions. So again, here, that's going to be 3 to the 4th over 7 to the 4th. You're just applying that exponent to everything in the brackets. W to the 8 over Z to the 8. Okay, and then here, we've got 2, so basically, if I do this in 2 steps, I've got 2 squared to the 5th over 5 cubed to the 5th, and then use the power laws for that. Okay, so that would be 2 to the 10 over 5 to the 15. You can do that all in one step if you're good with that. Okay. So those are the basic laws. Let's turn over the page. Now we're going to simplify and evaluate. Okay. Okay, are we all doing this? Are you good? Have you done them? Okay. Hudson, are you good? Okay, so here, single power. So we keep it to 12 minus 9 is 3, and now evaluate that. Okay. If there's brackets, you keep the brackets. We're multiplying, so we add the exponents. Now, even exponent, 10, means we've got an even number of negatives, which means it's going to be a positive. And then 2 to the 10, challenge yourself. Can you do it without a calculator? Right? 2 squared is 4. So 4 to the 5th. I might need a calculator too. If it just said evaluate, no, 1024. If it just said evaluate, then you could find the value of each factor and multiply them together. But it said to show as a single power first, so we have to show that step. Okay, so as a single power here, power of a power, we're going to multiply those exponents, so it's to the 6th. And then you can show it as 3 to the 6th over 2 to the 6th, or just evaluate it right away, up to you. So 3 to the 6th is 729, and 2 to the 6th is 64. Can't reduce. because 2 doesn't go into 3, right? If it could reduce, then we could have reduced the fraction to start because we were raising it to the same exponent. Okay, a few things to do in D. So remember order of operations, you kind of got to do the powers first, deal with the exponents, then multiplication, numerator first, then multiplication and division. So here, showing my work, that would be 6 to the exponent 6 times 6 to the exponent 8 over 6 to the 12. Now in that numerator, we're multiplying, so that's 6 to the 14 over 6 to the 12. And then we're dividing. So that's 6 to the exponent 2. So we're subtracting the exponents. So that's showing your work, which we will be asking you to do on a test.
Is this going to be on the
Quiz? No.
Oh, okay.
Today's stuff isn't on the check-in quiz tomorrow.
Oh, okay.
It's up to Friday's work, radicals. Okay, which is larger? 3 to the 444 or 4 to the 333? Put it in your calculator. What happens? Error.
3 to 444.
It is an error. It doesn't give you. In a TI, it's called overflow. I think maybe in a Casio, same thing. It's so big, it won't store it in there. Okay. Pardon me? Is it? Okay, let's check it out. We got to think of a way of figuring this out. So take a look at the bases. Any common factor between 3 and 4? No, common factor goes into it. No, 3 is a prime number, right? Okay, 333 and 444. What number goes into both of those? Bigger than 11. 111. Yeah, so we could show this as 3 to the 4th raised to the exponent 111. We can show this as 4 to the exponent 3 to the exponent 111. So now the outside exponent is 111 for both. Inside, 3 to the 4th is 81. And 4 to the 3 is 64. So which do you think is larger? 3 to the power of 444. This one's larger. Okay, because 81 is bigger than 64, and they're both raised to the same exponent. Okay. Is there any special law for adding powers with the same base? Look in the chart. No, there's no law for that. Okay, so there's no law for adding powers with the same base. Okay, getting into a little bit more with variables. And so when it says simplify, that's really, we reserve that word when we have variables. Still means we might need to evaluate some of the number parts of it, but it really means there's some variables in it. Oops. Okay, so here we've got 2 in brackets, 2a squared, the other bracket a to the 4th. So the 2 is just 2 by itself, multiplied by whatever the exponent on a is. Okay, because really the coefficient on a to the fourth is 1. So who can tell me the exponent there? Hands up, hands up. What's the answer to that one? A squared times a to the fourth is what? Yep. Yep, good. You add the exponents. Okay. Got to think about the order of operations. So in the next one, we've got 7p times 2p cubed in brackets raised to the exponent 0. So we've got to do this part first. Okay. Anything raised to the exponent 0 has a value of what? 1. 1, 1, 1. So this is 7p times 1, which is just 7p. Okay, order of operations. So we do that part first, and 1 times anything is itself. This is a common mistake that I get on C. Okay, so what did I not do or do? Yes, I did not square -3. So don't forget, be kind to everything in the brackets. Treat everyone equally. So remember that law, if we look over here, that power of a product, I'm just going to erase that, says every factor in the brackets has to be raised to the exponent m. So here, -3 is in the brackets, so it needs to be raised to the exponent 2. Okay, so I sometimes show 2 steps. You don't have to, but I go, okay, -3 in brackets squared, and then I did the n to the fourth squared in my head, and then I evaluate that. So now a negative squared is a positive because it's in the brackets. That's an important one to remember. Students forget about the numbers in front. Next one, again, order of operations. So I've got to do this part first. Power of a power is n to the 6 times n to the 4th over n cubed. So then multiplying that, that's going to be n to the 10. You add the exponents over n cubed. And then finally, n to the 7. Sometimes you can take steps. Sometimes it might just be 1 mark for that one. So if you want to do all of that in your head, you can. All right, so the practice is there for you. And it's, yeah, fairly decent. So that should, you can work on that to the end of the period. You have your textbook now since Friday. So the textbook questions are listed there as well. So you can work on those. As well, the textbook is posted in D2L if you didn't have your book with you.